Okay, let's get started. Welcome everyone to the Social Data Science Center Symposium at the University of Maryland. This webinar is being recorded and will be made available on the SoDa website next week. We will have time for questions at the end of the presentation today. Please use the Q&A feature, not the messaging feature, but the Q&A feature at any time during the symposium to write your questions. If you would like an opportunity to ask your questions live, please make a note of that, and you will be called on and unmuted during the Q&A portion. Now it's my pleasure to introduce our speaker for today, Yamil R. Velez. Yamil Ricardo Velez is an assistant professor of political science at Columbia University. His research focuses on how the quality of political information influences political engagement and representation, with a particular emphasis on the impact of misinformation. His most recent work explores the potential for generative artificial intelligence to enhance our understanding of public opinion through the use of adaptive surveys. His work has been published in top journals such as American Political Science Review, American Journal of Political Science, Journal of Politics, British Journal of Political Science, and Political Analysis. At Columbia, Yamil teaches courses on experimental research, political psychology, and racial and ethnic politics. Before joining Columbia, he held faculty positions at George Washington University and Wesleyan University. And he holds a PhD in political science from Stony Brook University. So it's my great pleasure to welcome Yamil. The floor is yours.
Thank you so much, Chris. And it's a pleasure to present my work in front of, it seems like, an audience of folks who specialize in survey research and public opinion research, which I would say is certainly a niche that I appreciate, and it's I would say departs from my typical audience, which tends to be mostly political scientists. But I'm really looking forward to getting feedback, and also especially seeing if any of these methods can be useful for you. And I'll talk about implementation later, which I think is one of the biggest challenges with this project. So getting feedback from people who use this tool would be immensely valuable. So today I'm going to talk about crowdsourced adaptive surveys, and what motivated this project was that we are currently in an environment of information overload. And, capturing public opinion to begin with, right, entails measuring a moving target, but rapidly changing information environments complicate this objective. We have encrypted chats, niche communities, algorithmic feeds that render the legibility of opinion more challenging. So when we as experts are devising our surveys, it introduces complexity in terms of, what kinds of issues should we include? And if we're measuring beliefs, what kinds of beliefs should we measure? Attitudes, right? And so what I, thought would be a good approach in light of, I think, all of this complexity and some of the barriers that we have to gauging public opinion in this environment, is to see if we can introduce more kind of adaptivity into the survey process. And so this is in some ways a response to some of the challenges I've faced when conducting public opinion research, especially during elections. So some of the challenges with static surveys or more traditional surveys is lag time, right? So we often might have out of distribution events, right? So the announcement about the global tariffs, right? That was something that came out of nowhere, right? It was a very unexpected event, and it might be hard for our surveys to actually pick up on how the public feels about this topic, at least for academic researchers, we have to, obtain, IRB approval for, our surveys, which can take, several weeks, right, or months, depending on your institution. And by the time our surveys are approved and ready in the field, the political environment has changed. And so it can make it hard for our surveys to respond to what's going on, nationally. There's also the challenge of expert gaps that, there may be a mismatch between the concepts that we include in our surveys and how participants actually think about them. So we might measure political participation, from our perspective as, social scientists, but it might depart in important ways from how the public views the concept, right? So behaviors like protesting or, calling a city councilor might be seen as a stronger indicator of political engagement if we just ask, let's say, ordinary voters relative to something like voting, right? And we might not know that, if we go in with a strong kind of, take on what political participation entails. And, this can lead to unacknowledged concerns, priorities, norms that, we're gonna be missing in our surveys. And so the core question and what motivates this idea of a crowdsourced adaptive survey is how can our survey instruments, keep up basically with these dynamic, heterogeneous information environments that we find ourselves in. And so what crowdsourced adaptive surveys try to do is basically unite these kind of three concepts under the same umbrella to, again, kind of have our survey instruments evolve and learn from participants directly. And so, we have the notion of wisdom of the crowds, that, you can ask participants questions often about, empirical quantities, and while individual participants might be far off, there are often cases that, when you aggregate, opinion actually gets pretty close to actual objective indicators. And, I want to say here that crowdsourced adaptive surveys, the idea is not necessarily to capture something objective per se, but instead to use participants in some ways as, as co-creators of the survey with us. And so they might, for instance, surface considerations or concerns that wouldn't be on our radar. There's also the large language model, right? So part of what made this project possible was, these significant advances in natural language processing, where we have these models that can generate text, can summarize text, can classify text to an extent that often gets pretty close to human performance. And so this kind of project would not have been possible 3 years ago, 4 years ago, but is increasingly possible now because of these advances in NLP. And then also kind of incorporate the role of adaptive algorithms here. This will become, I think, clear as the talk goes on, but we're going to have a situation where we have many participants submitting content that ultimately becomes a survey question that can be presented to other participants, and we need to find a way to prioritize these different questions, right? So we might have 1,000 participants, and from those 1,000 participants, maybe there are 700 usable survey questions. At some point, we have to figure out a way of distributing resources in terms of where we're allocating our participants, so to which kinds of survey questions. And so this is where I use multi-armed bandit algorithms, which emerge out of computer science, to figure out a way of allocating participants to survey questions and prioritizing what are the most promising survey questions. So crowdsourced adaptive surveys, in terms of the sequence of events, it takes the raw materials of respondent inputs, and you'll see basically the bread and butter of the crowdsourced adaptive survey is an open-ended question. It converts this unstructured text, which varies across participants. Often you'll have participants mentioning one word or writing a sentence, writing a paragraph. We want to find a way of standardizing this, so we use large language models to convert them into structured survey questions. And then once we have a bunch of these structured survey questions that were submitted by participants, we use adaptive algorithms to prioritize the most promising survey questions, because you run into issues with with actually being able to estimate these quantities that you might care about when you have so many items floating around. And so I'll talk about the different algorithms that might be used. And I'll preface this by saying I'm not a computer scientist, and so I use some algorithms off the shelf. There may be optimal algorithms for your task. And that's going to be, I think, where I would love to see some of the future directions in terms of this broader kind of framework. So the general process here is I gather open-ended responses with respect to some kind of question I'm interested in. So in the paper, I talk about, and this is published in Political Analysis, I ask about issue salience and also negative claims or misinformation or rumors that are floating around about political parties and candidates. And so with both of these cases, there's an open-ended question. And participants basically write in a free form about these different topics. And I use a large language model to basically convert these responses to structured questions. So someone might say, I care a lot about abortion, for instance. And when presented in the context of an issue importance scale, I care about abortion basically becomes abortion, right? So we find a way of taking this unstructured text and converting it into something that mirrors other survey questions that we might see from Gallup or some other organizations. There are a lot of trolls online, right? And so I also apply toxicity filters. So we want to make sure, for instance, that if someone says something offensive or submits gibberish or something along those lines, we want to find out ways of actually ensuring that the survey questions that are inserted into this, what I call a question bank, are valid and legible. And so there's application of a filter for toxicity and then a redundancy filter. The reason why I include the latter is because you might have multiple participants who say, let's say, care about the environment. So they'll say, I care about environmental politics. Another person just writes environment. We want to make sure we're not including a bunch of redundant questions in the same question bank. And so this is where I use another natural language processing tool, an embedding model, which tries to basically sort through the similarity between the different text inputs. And I only keep those that basically are unique to within a certain threshold. And then basically participants respond to their own question. So they have a structured question, and then they respond to structured survey questions submitted by other participants. Those ratings are then used to update the probability of presenting these different questions using a multi-arm bandit algorithm. And then I'll show you later how these algorithms work. You can basically think about them as prioritizing. So the Gaussian Thompson sampling, which I use in the paper, will prioritize items that have higher mean ratings. So basically, if items are rated more highly on a scale, they are then more likely to be presented to other participants. And I'll talk about potential trade-offs if you use this approach versus a uniform probability approach where you're just assigning the same probability to every survey question. And we'll talk about the kind of benefits and drawbacks of these different approaches. And then here in this figure, basically, before you start the study, you have to include what are called seed items. And seed items are basically an initial set of items that participants can rate, because basically no participants have submitted any questions yet. So it's good to have some initial questions. And what's interesting about the method, right, is that often you'll recover items that are submitted by participants that often surpass those seed items. The seed items, in some ways, you can think about this as what are your priors or your hunches about what might be important to your participants. And then, what's nice about this method is that you can basically assess, to what extent are the participant-generated items receiving higher ratings than the items that you thought would actually perform better. So here I use Gallup. At the time, these were the top issues from the most important issue question. And I'll talk about the misinformation case where some claims were drawn specifically from the Spanish language fact checkers. And often what you'll find is the participant generated items will outperform some of these items. And the point here, again, is not to make this a horse race, but instead, usually the seed items are, you just have to do it by necessity because no other items have been rated when the first participant enters your survey. And I'll talk about this kind of sequence of events later. So Step one of a crowdsourced adaptive survey is to elicit opinion. And so what you want to do is prompt users in a way that extracts useful information and can be helpful in terms of this survey question construction. So, we'll talk about the case of trying to extract rumors and misinformation from Latino voters. And, you can imagine, right, you would probably not receive the most useful information if you just ask people, tell me about misinformation, tell me about the misinformation you're seeing. And so in that study, I specifically prompted people to write about negative claims, things that make parties or candidates look bad, as the open-ended question. And so, it required a lot of thinking about, what are ways of trying to get at this concept in a way that doesn't impose my particular definition of the concept on the participant. And so this is what we might do for misinformation. For issue importance, right? We might ask people, right, what is an issue that you care about, that you follow on a regular basis, right? We want to extract as much information as we can from participants to then convert this into the survey question. And so in the case of misinformation, for politicized events, false claims and rumors, it was, name a negative piece of information about political parties or candidates. For issue salience, we might ask, what is an issue that defines the way you think about politics? Now, you might think to yourself at this point, right, like participants are going to vary in terms of, verbosity, formality, there will be spelling errors, right? And so we don't want to just take raw text and then present it to future participants, right? We want to make sure there's some quality control. And so this is where the large language models come in. So there's variation across respondent inputs, and we might want to standardize the content to make sure every item has a fair shake, right? If for instance, we just submitted an item where there was a misspelling, that might have a lower rating than one that had, that was properly spelled, and therefore that issue area or that claim that we're testing might not receive, an adequate, test, right, because of these issues. And so this is where the large language models get incorporated. So I'm sure, given so much interest and engagement with these tools, we already kind of know, what this concept of large language model is, but just for those of you, who might not know, like large language models are these large parameter neural network models that can perform a variety of tasks at or near the level of human experts, tasks like text generation, classification, and summarization. And there's a recent paper by Jonathan Mellon at West Point and colleagues published in 2024 that found that in terms of classifying the most important issue for the British election study, large language models like GPT-4, Anthropic's Claude did a really good job of getting close to human expert classifications. And so, these tools are very powerful. And there are issues like hallucinations. I would say in the context of generating survey questions, though, because the task is summarization, they tend to perform fairly well, I would say. And so and my suspicion is they'll become even better as time goes on. And so the idea is to basically use the LLMs to take unstructured text, like I think it's too expensive to own a home these days, and convert it into usable content for survey questions. So for an issue, most important issue question, or something along those lines, where people might be rating different issue areas and indicating importance on a Likert scale, rating an entire sentence would not be feasible, or it can be a little complicated. It also might distract people, right? If there are different lengths and levels of formality. So instead, we can take the LLMs to take that raw text and convert it into something usable, like just housing prices. We might also want to incorporate filtering. So these structured survey questions could be added to a question bank, and then then they're presented to future participants, and this could be unrestricted, right? But some of the problems here are redundancy and toxicity. So redundancy here would be, again, someone says the environment, another person says environmental politics. They're basically getting at the same issue area, and so you're duplicating content in the question bank. And so we might want to consolidate so that we make sure that those issue areas get as many ratings as they can, as opposed to being split among different variations. There's also the problem of toxicity. So it could be the case, for instance, that people are submitting slurs or curse words, and so we might be worried about including that in a question bank. That probably wouldn't fly by certain professional standards. So this, all of the content gets run through a moderation API to ensure that we're only including stuff that isn't flagged for being offensive or harmful text. And so I use embedding models to filter out sufficiently similar questions. Embedding models basically try to place text on a similar kind of semantic space. And so what you'll see, for instance, is that with these models, housing prices and housing might receive very similar kind of embedding scores, and housing prices and animal rights you might see a larger gap in terms of what's a metric called cosine similarity. And so what you can do with these embeddings is say, I want to only include words that are sufficiently distinct. If I have housing prices and excessive costs of housing, I want to make sure that that we're not adding a bunch of redundant questions. And so this is how the embedding models can help on that front. For toxicity, I use the moderation APIs to filter out offensive text. So in terms of presenting questions, right? So we could, take, let's say, 50 questions submitted by participants and present them to the future participants with equal probability using a uniform distribution. So we present items regardless of ratings. So there's no, stacking the deck for certain items over others. Now, in the paper, I talk about the uniform probability, question selection approach as being useful if you don't want to prioritize high ratings or scores. So for instance, maybe you're getting at a bunch of descriptors of personality, and you don't want to just capture the most prevalent, let's say, personality traits. You also want to get low prevalence personality traits. So in this case, maybe the uniform sampling would make sense. But the issue here is that you might waste resources on poorly performing questions. So sometimes, because this process is automated, you have people submitting text. It's then summarized and included in a question bank as a structured question. It could be the case, for instance, that this is not, given your limited resources in terms of how many eyeballs you want on these survey questions, there could be certain survey questions that are, poorly phrased or, about an issue that's not important. And so you might want to figure out a way of actually prioritizing certain items. In the case of misinformation and rumors, you might want to prioritize rumors that are believed by a larger share of the population versus those that are, far-flung kind of conspiracies that very few people believe. And so this is where I introduce the Gaussian-Thompson sampling, which is kind of premised on this idea of, essentially prioritizing items that have higher mean ratings. And so the logic here is, if you're trying to capture prevalent, let's say, misinformation or rumors, or you're trying to capture salient issues, you might want to prioritize those that have higher ratings on, let's say, an issue importance scale, or let's say a belief scale for misinformation. And so for issue salience, we might want to prioritize issues that are rated as more important by participants on some Likert scale. And one of the costs, I would say, with a Gaussian-Thompson sampling approach is that you learn less about these low prevalence or disliked items. So there may be cases where you actually care about the low end. And so Gaussian-Thompson sampling will not be, I think, the best algorithm to use. But I think for a lot of cases where we do care about, let's say, prevalent beliefs or attitudes, Gaussian-Thompson sampling, makes sense. So the general logic here is Gaussian-Thompson sampling. It tries to balance exploitation and exploration. There's an exploitation kind of objective of these multi-arm bandit algorithms, where the idea is to find, let's say, best performing or high performing items and then allocate more participants to that. But you can imagine, right, this creates a trade-off, because if you allocate more participants to promising arms, there might be some that you haven't explored yet that should receive more attention. And so there's an exploration aim that you might be worried about. So you might want to allocate more participants to testing new or uncertain items to discover, more promising options. And so Gaussian-Thompson sampling tries to kind of balance these two objectives. And so not putting too much weight in just taking all of your participants and sending them to the most promising item, let's say the one that has the highest issue importance rating, and then not doing full exploration where you're just, let's say, exploring everything with a uniform probability. And so how does this method depart from like the other adaptive methods that have emerged? So there are computerized adaptive testing approaches that have been proposed for surveys, but these generally require a latent trait. So you have to have, let's say, some latent trait you're interested in measuring, something like political knowledge, where you already have 20 or 30 items. And then what CAT does is it tries to prioritize which items to present to participants based on how informative those items might be with respect to the latent scale. So you might ask someone an easy political knowledge question, they get it right. You get to a medium difficulty political knowledge question, they get it right. And then you serve them a hard political knowledge question to then get a better sense of where they stand on political knowledge. But as you can tell from this requires already having some items in place. And so the whole idea of this crowdsourced adaptive survey is that this is when you're venturing into a space where maybe the items have not been generated yet, and you kind of have to lean on your participants for this. There's also wiki surveys. So wiki surveys have a component of adaptability. Often what wiki surveys involve are basically this idea of having these pairwise comparisons. So they've been used in like budget allocation tasks. So should, for instance, the city council devote resources to addressing, let's say, housing or education, right? And then people are making these pairwise decisions. And it also allows you to submit an issue domain for these pairwise comparisons. The challenge is like it kind of enforces this zero-sum situation, again, where you're choosing between these pairwise options. And so crowdsourced adaptive surveys not only have a component of adaptivity, but it also there's range in terms of the outcome variable. So you can use Likert scales, binary items. There's virtually no kind of limit in terms of what scale you're using. All that matters is that you have some kind of defined outcome that you can use for optimization. So the first application presented in the paper is national issue salience. Here I use a convenient sample by Cloud Research Connect. It's conducted in September 2023, a quota-based US sample balanced on age, race, and education. And this was 820 US adults. And the objective here was to capture issue salience using open-ended questions about a prioritized issue. So here I basically asked people, like, what is an issue that you care deeply about in an open-ended format. In this study, I had 8 dynamic slots. So this meant that basically people were presented with 8 questions from the question bank. And then because of the 8 dynamic slots, I had 8 seed items. And these seed items were basically determined by the highest ranked items at the time, according to the Gallup most important issue question. So these span, a variety of issues, including immigration, the economy, race relations, and so on. So this is what the output of the crowdsourced adaptive survey approach looks like. These are for questions that received 10 or more ratings. And what you'll find is that you get a ton of items. So because participants are generating the content, often each participant will actually submit something that's usable. And so you'll see that you get a ton of items. You do get point estimates and uncertainty. And what's valuable is you could see, for instance, the LLM will often make decisions about whether to use a coarser or fine-grained categorization or classification. And so for this sample, for instance, if you look at the highest performing or the highest rated items in terms of importance, they all tend to do with they all have to do with things like things like cost of living, different dimensions of healthcare, the economy, and so we see like a lot of those items kind of clustering toward the top. And some of the items that were included as seed items because of the Gallup ratings, you'll see they kind of occupy the lower end. And so what I would say is helpful about this approach is that you're getting tons of issue importance ratings, getting a sense of where where the sample might fall in terms of these different issues, and some interesting items that I probably would not have included had I been constructing the survey. Questions like dealing with different things like political accountability, for instance, that would not have been top of mind for inclusion. I realize I have 10 minutes left, so I might have to kind of breeze through some of this. This is all in the paper, but another neat thing about the crowdsourced adaptive surveys is that you can also conduct subgroup analyses across a variety of issue dimensions. And so, for instance, in terms of mean importance, we find really big partisan gaps with respect to things like income inequality, universal health care. But then this method also allows us to see areas of consensus across subgroups. And so for things like political polarization, healthcare costs, we actually see some minimal differences between the partisans responding to these questions. And so it basically allows you to explore subgroup heterogeneity on domains that maybe you might not have included in your survey. So this is all, again, in the paper, and I want to make sure I talk about implementation, because that's one of the biggest hurdles with this approach. This is another application where it's often hard to know what kind of claims you want to assess if you're interested in studying rumors, misinformation, false claims. And so this method can be really helpful, especially in cases where people are using encrypted chats, like in the case of many Latino voters and often some immigrant voters. And so it can be really helpful to learn from participants themselves about what they're seeing online. And so this application of the crowdsourced adaptive survey basically used 4 dynamic slots to explore beliefs about a variety of claims that were circulating during the in 2023, and I used seed items that were drawn from 2 prominent Spanish language fact-checking websites. These were on the front page. And what was helpful about this method is it actually, I was able to get a sense of the kinds of claims that people were actually buying into and consuming. And so in the paper, for instance, I find that a lot of the claims that people mentioned when they're asked, name a negative, fact or claim about political parties and candidates, often they're referring to party stereotypes, referring to actually genuine newsworthy stories like scandals. So one of the most highest rated claims was one about Ted Cruz, fleeing to Cancun. And so objectively false claims actually were rated as some of the least accurate in the sample. So those points that you see as indicated in gray, those were the ones that were prioritized by the fact-checking websites at the time of the study. So what we find is that these objectively false claims, actually very few Latino voters in the sample actually saw the claims as accurate. Instead, it was these newsworthy scandals and party stereotypes. And so it tells you a little something about this question about misinformation and its prevalence, right? So among Latinos, the crowdsourced adaptive survey mapped which claims were traveling, who believed them, and how strongly. Now, one of the biggest challenges with this method is that you have to kind of wear 3 hats. You have to, you're doing prompt engineering, you're working with embedding models. You also want to be a good survey researcher. So you want to ask good, open-ended questions. And then you're also doing database programming, right? Because the updating of that question bank underlying that is a database. And so what I've tried to do, at least over the past, couple of months after this paper is published, is to develop a tool that actually allows you to carry out these surveys in a much more straightforward way. And so I've been building out a user interface that allows you to kind of walk through the different steps of how to implement a crowdsourced adaptive survey. And this is currently on my website at taylorexperiments.com. For now, it does require working with this platform called Replit, which makes it very easy, basically, to host, your own database and set this project up on your own. I am trying to figure out other solutions to this, but right now, the tool is available that you can use in your work. And what I would especially appreciate is to get any feedback on how to, on your interactions with the tool and what can be made better. And so this web application allows you to choose your own large language model. It can be open source or closed source. You can vary some of the parameters that I describe in the paper. There are different ways of implementing it. So you can implement it in Qualtrics, what I call the hard mode, where you have a lot of flexibility over the way that you present the items. You can have it, using your own university's branding, for instance. And then I have an easier mode, which is described as like a self-hosted example, where you can have it as an embedded web page. And so you can actually use this with basically any survey provider, SurveyMonkey, Qualtrics, that allows you to embed web pages. And then I have a playground that allows you to validate different prompts. So we have basically, the prompts that are set up are for issue importance, classification. But it allows you to set up your own prompts, and then you can also test out the prompts and set up your own filters. And you can also learn how Gaussian Thompson sampling works. Okay, so I have 4 more minutes, so I kind of want to get through this quickly. Some of the caveats and concerns: there's a concern about late arrival bias. So that is a challenge, right? So if an item that is like a really good survey item is mentioned at the end of the survey, you can't do anything about it. Now, one possibility is you can think about this as an extended kind of survey that, over time, right? So this could be your first survey, but the next survey could continue where you left off. What's nice about these multi-arm bandits is that you'll have probabilities of question presentation that you can then apply to the future surveys. And there are ways like inverse probability weighting that allow you to adjust for this issue that some items basically get a better shot in the beginning, and it allows basically these early items to be downweighted. There's also sample drift, so your sample might change over time. There are diagnostics you can run to make sure that your sample composition isn't changing radically. The alternative algorithms that I describe in the paper haven't been implemented yet, but they're promising. And then there's prompt sensitivity. And here, validation is key. You want to make sure your prompt is doing a good job of converting the unstructured text into structured text. And then there's also prompt sensitivity with respect to people, right? You might want to ask descriptive questions that can be used as a basis for survey questions. So we have to think deeply about how to do that. Okay, so I see some comments. Okay, got it. Okay, and then in terms of the different caveats and additional caveats and concerns. Does this conflict with static surveys? No, you can still use your preferred kind of survey questions, and then you just allocate a few slots to these adaptive items. And this can serve as an inductive gut check. So you can go in with maybe some questions that you were on the fence about. You can include those as seed items and then see how those perform relative to the participant-generated items. And then you can also take what you've learned from the crowdsourced adaptive survey, let's say in an initial survey, and then apply it in a subsequent one, right? So from let's say that issue importance paper, or rather an issue importance example, we learned that healthcare was really important in the sample, as were things like privacy protections, right? And so we can include that as a fixed item in the future survey. So we can think about it as a kind of an inductive pilot that allows us to then settle on static items later. The cost in terms of using the API is less than $0.01 per participant. So these tools have become increasingly inexpensive, and so you're not paying a ton to do the actual to do the LLM standardization. In terms of privacy and data concerns, proprietary APIs such as OpenAI guarantee that it will not train on API submitted content. Now that requires you to keep up, with the updates if they do change this policy. That being said, open source models are catching up, like Llama, and you can actually self-host these in some cases. So you can often find, an Amazon web server that will allow you to host some of these large language models, and so you can ensure that whatever information is being submitted to your large language model is yours, and you know where it's going. This I would say is positive development. These open source models are getting really good, and you can even try it with the tool I've developed. You can include so there's a platform called Open Router that allows you to test different open source tools, and so you can actually test them, let's say, before deploying them on your own. So crowdsourced adaptive surveys unites generative AI and adaptive algorithms to try to construct these useful surveys that are co-constructed with participants. In the paper, I applied to 3 issue domains. I didn't talk about local concerns, but you can imagine, right? You're interested in public opinion in New York City. You don't, you might, you might be a resident, but you might not know exactly what people care about in the city, by virtue of the kinds of people you talk to or where you go, right? And so that could be another space where you're interested in conducting an analysis of issues or concerns within a niche population. This tool can be helpful for kind of extracting some of those insights. And so one way to think about this is a helpful inductive approach to devise new items, learn on the fly about public opinion, and increase connections between respondents and researchers. Now, there's more work to be done on testing different algorithms. I'm not a computer scientist, so I kind of relied on 2 fairly popular ways, I would say, of trying to distribute these items with uniform sampling and Gaussian-Thompson sampling, but there are certainly others. There's also the possibility to balance multiple objectives. Maybe you don't just care about issue importance, you also care about how polarizing the issue is, right? And so, finding out algorithms that balance the multiple objectives, I would say, is another kind of a place to take this. There's also prompt engineering. So how do we, construct the right prompts to get the right level of granularity when participants submit something? And then there's also inference. So basically figuring out, so there's been a lot of work on this recently about adaptive algorithms and what the appropriate standard errors are and so on. Now, if you're worried a lot about this, right, again, you can always take the inputs from a crowdsourced adaptive survey and then run it on a fixed survey in the future if this is really keeping you up at night. So I see this as a tool that kind of bridges researchers and respondents. Researchers, we give our respondents questions, we get responses as a consequence. With large language models, I see them as a way of kind of bridging the gap between the two. Thank you, and I'm really looking forward to getting some feedback from Froika. And if you have any kind of questions, feel free to reach out. And tailoredexperiments.com is a website where I host a lot of the adaptive survey work I've been doing over the past few years. And you can play around with this crowdsourced adaptive survey tool. And again, I would love to get feedback on ways to improve it, because I'm not a UI engineer, I'm not a computer scientist, but I want to take the feedback seriously so that other people adopt this approach, because I've found it very useful. So thank you.
Thank you, Jamil. Maybe you can unshare your screen and you can see you here. Perfect. Thank you so much. And I love the fact that you had the 2 hat slides in there. I too am with 2 hats here. You can see I still have my badge from the conference here at Columbia. So thank you for joining us. I had to smile because some of my comments and would have elaborated on a little bit as a start of our discussion here were these comparisons with these other survey types that you mentioned, the wiki survey and the other adaptive testing sites. And you stole my thunder there by diving into them. But one thing that you didn't address, and I would like to hear your thoughts on that. These other approaches were exciting when they came out, and then it stayed a niche thing, right? They haven't taken off. They haven't revolutionized how we do surveys. And I'm curious to hear why you think that was the case, and how this approach here can be launched into the community differently so that it has a chance. Could you speak to that a little bit?
Yeah, so I would say the hardest part about this project has not been like running the studies. Once you have the kind of the stack ready to go, it's pretty easy to replicate. I would say the challenge is finding a platform, and I might have to design it on my own, is what I'm concerned about. But it's that you have all of these different moving parts. So you have a large language model, you have an embedding model, and you have a database. And I would say a lot of social scientists, like, they might not have a lot of experience with these tools. It might seem very daunting to pick up all these different areas of knowledge. Whereas for Qualtrics or SurveyMonkey, you can just go in and you point and click, and you design your survey and you deploy it. I've tried it as hard as I can for now, I think, with making it user friendly. So what I have hosted on my website now It does require signing up for this platform called Replit that allows you to then reproduce my code, and then you can make your own adjustments. But right now, this is I think what I can manage. But I would say for the next year or so, I do want to think, about whether this requires developing my own kind of survey platform for these kinds of studies that make it super easy, where you just, you sign up, you create your survey, and it's, as easy to use as something like Qualtrics or SurveyMonkey. So for now, I'm somewhere in between. It's like figuring out ways to pipe this into a Qualtrics survey. But yeah, as you can tell, right, like there are a lot of moving parts, and
yeah,
I would, that's the biggest barrier. Yeah.
And I think your intuition to have a way to get to know it using existing infrastructure is probably a good one, to get that into the community. I looked at the Q&A questions, and there was one that you probably also see asking about the small sample size that you had there. And this is sort of tied into the question I had, it's like, was this sort of piloting, or do you think there's something with this approach? It just makes it very difficult for respondents to stay on task.
So at least in the two cases that I had here, I thought about it as like a really helpful kind of pilot that it's a highly inductive approach. I would say like the large language models I tested at the time, they may be better now. I haven't worked with the reasoning models that have come out more recently. You still have, they struggled with the task of, at least for issues, for instance, the issue of issue granularity. So healthcare showed up multiple times, even with the embedding, healthcare affordability, healthcare costs, universal healthcare, all came up and were added to the question bank. I think in part because the model was instead of, let's say, assigning that to healthcare, it was figuring out all these different like granular dimensions of healthcare that it included. Now, I guess it depends on what the goal is. If we just care about whether healthcare is the most important topic, then maybe we want the coarser, the coarser categorization. But maybe if we care about healthcare, like different dimensions of healthcare, then the more granular approach is optimal. I would say that because of those challenges, I didn't run it, let's say, with a full sample. Instead, I treated it as more as like as a pilot to say like, hey, healthcare is coming up a lot, so let's maybe include that as a fixed item in the future. Things like privacy considerations too came up. So yeah, I would say there's still maybe the performance it still requires some kind of human eyes on the process to make sure it's working correctly. But I would still say it's very, for me, it was informative. There were things that I did not have on my radar, like things like corruption and transparency about candidates that I would not have included in my survey. And the same thing with the misinformation case. I think a lot of the misinformation literature, it's just they rely on what people are fact checking, but often there are things that are salient to participants that are actually genuine information, and that we wouldn't include in a fact checking study because we're not asking participants.
Yeah, I think we have two people at least that raised their hand to speak their questions live. One is Stephanie Ekman and the other one, Rachel Horwitz. So Chris, I think you have the power to make that happen.
Is that me? Hi, everybody. This is Stephanie. Stephanie Ekman. I'm at the conference or the workshop with Raka today, and we are hearing a lot today about synthetic respondents. And forgive me, I was a little bit late, so I hope you didn't cover this, but I'm wondering if you've tried this process with synthetic respondents to get a sense of what to do like a first pass at surfacing the important topics.
That's a fascinating idea. No, I have not. But you could imagine, yeah, that's a good way of a pilot before the pilot to make sure that, because yeah, I would say So for me to settle on the prompts that I did for the large language models for these projects, it was mostly me basically trying out different issue domains or trying out different claims and seeing how the LLM processed it. So a lot of it was like, yeah, me directly testing it, but you could imagine it could be helpful, yeah, to have the maybe large language models as a first pass to fill out those open-ended questions and then see what they're doing. And if you're not happy,
Yeah, I mean, that's the
prompt. Yeah.
sort of the emerging consensus today at this workshop is like maybe what they're good at right now is pilot testing.
Yeah.
Right.
Yeah.
So that's why this occurred to me that it might be nice for you.
No, that's a great idea. Thank you.
Thank you.
Great. And Rachel, are you in a place where you can speak your question out loud?
I don't know if Rachel is still here.
Oh, okay. All right. Then I'll gonna jump back to two things that we saw also mentioned on the general chat. You mentioned that sort of in passing. Given the somewhat unpredictable nature of the LLMs, when you issue this as a grant proposal or a research proposal, IRB might be much more challenging, right? Because you don't have a structured survey that you submit that can be approved, that can be looked at. What was your experience there? Do you have any guidance for anyone who would want to try this out?
So my experience with IRB was as long as I could, convince them that the toxicity, like there were that basically there were steps in place to make sure that people weren't presented with offensive kind of toxic content. They were okay with it. And so that's why in the paper, like I advocate for the toxicity filters, not because the large language models will produce it. Honestly, like the large language models now, they've come a long way. They often will refuse, right, to if you write anything that involves a racial slur or an offensive term, like generally, like it'll refuse. And you can, if in terms of the prompting process, you can also say, right, you can actually ask the large language model if anybody says these terms, then basically don't produce output or produce a canned question. And so, yeah, I would say that for the IRB, what was important was that there was a process there, that it was, yes, it's unpredictable what these LLMs are going to produce, but at least having some safeguards in place. And so the toxicity filter was an important part. I talk about it in the paper though. So one of the challenges with toxicity filters is, sometimes political scandals entail really toxic things about what candidates are doing, right? And so there was a case where there was someone accused of doing something pretty harmful, and the toxicity filter didn't allow it to go through. And so there are some questions about, like, yeah, the trade-offs of, but at least in terms of, I think preventing harm, which the IRB was concerned about. I made sure to include that, and also with the crowdsourced for the web application, it's also built in. So it's the default is to have some toxicity filtering. But yeah, so there was a claim about a politician being the Zodiac killer, and that did not pass the toxicity filter, even though it's a rumor, right? That it's like would be worth kind of knowing how many people know, see it as accurate. But yeah, that's how I've gone through the IRB process. Is
one of my grad students is working on jailbreak, so she should not be so respondent then. But anyway, I related though to the kind of questions asked and answered. Another question that we saw on the Q&A was if you could explain a little bit more the nature of the questions that can be fielded. As you said yourself, there could be a variety. Some are closed-ended, some are open-ended. And if you think of the full gambit of sort of citizen science project, and actually your overview slide at the end, with the LLM being the intermediary between the researcher and the respondent, I think your work very nicely slits into this whole new movement to citizen science, right? There can be this interactive process. What could you describe a little bit the landscape of sort of the type of questions being asked, being available in your tool a little bit more?
Yeah, so I've used it for as I mentioned, like issue salience questions and misinformation. I have an ongoing project on political representation, so relating to the citizen science question. Basically, an open-ended question. People write about their concern, and what is then pulled in is actual bills in Congress that are under consideration or related to the user's concerns. And then what we can do is actually take those concerns and then send them to the adaptive question bank, so that future participants can then rate, let's say, issue domains that don't receive a lot of attention nationally. So like for one of them, for instance, there's a bill that tries to deal with affordable housing. And this is something that maybe we wouldn't include in the national survey because it's not a nationally salient issue, or at least, maybe it's not a polarized issue that Gallup would include. But through this approach, basically that emerged as one of the highest rated items, was one, basically a policy currently in Congress trying to address affordable housing. So that kind of one thing I've been exploring in this project is actually taking databases. So taking, let's say, databases of congressional bills, turning those into survey questions, and then bringing them into the survey, and then using adaptive surveys to figure out, nationally salient issues that maybe don't get a lot of attention. So, I would say that this probably is helpful in domains where you have a lot of uncertainty about which items to include. That was my, that was the case, especially for the Latino study, because it's not like I can go to some database that's like, here are all of the things that Latino voters are seeing online. And so what I wanted to do was learn directly from participants about, to allow them to kind of help me with the content creation here.
Yeah, maybe I can just add to that. So another point I want to make, and maybe pick your brain on this a little bit. We have a panel in the field on privacy perceptions, and not from the general public, but from experts, right? And with the idea of sort of capturing, a sentiment and a rising awareness of privacy problems that are out there, right? In new technology, I mean, happens every day, right? But the problem is, by the time we collect, maybe from a subset of experts, the questions, and then field them, and then, stuff has moved on, right? So what you describe is, in a way, the mechanism that, in particular with cutting edge topics or a specialized population that we as researchers might not be the specialists of, is particularly useful. Do you see that as sort of a niche area also where this tool could be helpful?
I agree. Yeah, no, I think, yeah. And what I like about the seed items is that you can take those expert hunches, right? You include those as the seed items, and so the survey begins already with people rating those initial seed items, and usually they get more attention, right? But you'll often find, and at least in both cases, the participant generated content surpassed the seed items in terms of the ratings. And so this could be a case where it's like you could use it, as a kind of an inductive gut check. Like, okay, let's include these seed items, and then there will be these participant generated items, and if they're performing better, they'll get more priority. But if not, then the seed items will rise to the top. So that's been what's kind of fun of running these surveys, because you don't really know what's going to happen at the end. It's like you don't know which items are going to get more attention. It's kind of, there's like a horse race aspect to it that I like.
Perfect. Thank you very much, Yamil. This is great, and I'm glad that we get you. What for me is a long April week. It feels like the conference already started. It's sad that you can't be with us next week in St. Louis, but I hope to see you at April soon in the future, or in some other format. Spread this information. And I would love to try this out with our SoDa Tab project. So thank you for coming. Okay. And Chris, final words from you?
No, I think that's it. I think this concludes the webinar. So you can see an email here on the screen for more information about SoDa events. Thanks everyone for attending. Appreciate it.
Thank you.
Thank you.